Okay, today we're going to look at a speed time graph, and this is the example we're going to look at. So here's our small graph. We're going to show our x and our y-axis on our graph. So as a reminder, this is our x-axis, the one that's horizontal, and our y-axis is vertical. All right, so on the x-axis, we want to represent time, and that's going to be measured in hours. So we see that our hours go from 1 to 10. So I'm going to represent our hours here on our x-axis, just like so. And I'm going to go a little bit further to 12 just because. Now on our y-axis, we're going to look at speed, and it's measured in kilometers per hour, as we can see right here. So this is time on the x-axis, and that's measured in hours, and speed in kilometers per hour on the y-axis. And we're going to have to measure to our highest speed recorded. So the highest speed recorded, it looks like, is right here, 17. So I want to represent all the way up to at least 17 on my graph. So I'm going to start here with 1 and go to at least 17. All right, and now I'm going to 18. Okay, now we want to plot our points. So for the first one that we're going to do, for hour number 1, our speed was 10 kilometers per hour. So I'm going to plot my point here at 10. For hour number 2, we were at 12 kilometers per hour. So I want to draw my dot here at 12. For hour number 3, we were at 5 kilometers per hour. So I'm going to draw it right here. For hour number 4, we were again at 5 kilometers per hour. And for hour number 5, we were at 5 kilometers per hour. Okay, for hour number 6, we were at 15 kilometers per hour. For hour number 7, we were at 16 kilometers per hour. For hour number 8, let's see, we were at 17 kilometers per hour. And hour number 9, we were back at 15 kilometers per hour. I think I missed one, so let me see. We have hour number 6, hour number 7, hour number 7, we were at 16. Hour number 8, we were at 17. Hour number 9, we're at 15. So right there. There we go. And hour number 10, we are at 12 kilometers per hour. So right here. Now I want to connect my dots. So from 1 to 2, from 3 to 4, 5 to 6, 7, 8, 9. There we go. That's what our graph should look like. All right, so let's answer these questions now that our graph is complete. It says, when did the object's speed remain constant? So anytime we have like a horizontal line, we know that the object is either at rest or it's moving at a constant speed. So right here, so this would be hours 3, 4, and 5. We see a constant speed. So hours 3 through 5. Question number 2. Where is the object's average speed decreasing? So anytime that the slope of the line is going downward, we know that that is a decrease in speed. So from hours 2 to hours 3, so I'm going to say hours 2 to 3, and we see another decrease in speed up here. So from hours, let's see, from hours 8 to 10, we also see the speed decreasing. All right, so that is an easy setup to a speed time graph. We're going to do another example on the next page. So flip it up. Go to the next page for me. So I'm going to keep that. You're going to have I've sent you some grid paper to use. And this is the data we're going to be looking at. So I'm going to get you started in setting this up because this is what they're doing for homework. Okay, so we have your times shown here. Let me edit this. Okay, so we have times shown here and here. So the chart's just big, so they just broke it up into two, but you're going to do one big chart. And your speed is shown here and here. So when we're doing our time, we want to show it on the x-axis and our speed on the y-axis, because this is another speed time graph. So our time goes from 0 seconds to 15 seconds. So we're going to at least number on our x-axis 1 to 15. And then on our y-axis, the highest speed recorded, it looks like, is I see 9. So we want to at least go up to 9 meters per second. So we'll probably say 10 meters per second. Okay, so let's look at this graph here. So again, I'm going to draw my x-axis here. And I'm going to show it my time on the x-axis, and it's measured in seconds. And the highest second recorded is up to 15, so I'm going to start here. 1, 2, 3. And I'm going to go to 18, okay? And then my y-axis, so this is x, this is y. The highest speed recorded is up to 9, so I'm going to say, let's go to 10. So we're going to start here. This is 0, so this is going to be 1. All right, so that is going to be speed here. Okay, now let's plot our points. So let's see, hang on one second. I'm going to keep that. Let's look here. So starting here at second number, at 0 seconds, our speed is 0. So plot your point at 0. For our first second, our speed is 2. For our second second, our speed is 4. So let's go back here. And so it says at 0 seconds, our speed is 0. So I'm going to show that here. Oops. All right, plotting my point. At the first second, we are at 2. So I'm going to plot my point here. At our second second, we are at 4. At our third second, we are at 6. At our fourth second, we are at 8. At our fifth second, we are at 8.5. So there's 8. So we're going to say 8.5 is right here in between, halfway. At our sixth second, we are at 9. 7 seconds, we are at 9. 8 seconds, we're at 9. 9 seconds, we are at 9. At 10 seconds, we are at 8. At 11 seconds, we are at 7. At 12 seconds, we are at 5. At 13 seconds, we are at 2. At 14 seconds, we are at 2. 15 seconds, we are at 0. So I'm going to connect all of my dots. Just like so. And that is the way my graph is supposed to look right here. There we go. Okay, now we can interpret our graph based on by using the questions and seeing how to answer it correctly. Question number 1: what was the average speed of the ball as it rolled down the hill? So I'm going to want to add up all of my speeds right here, and I have to divide it by the number of speeds I have. So I have 15 points plotted on my graph. So I'm going to add up all of my speeds and divide by 15. Number 2, it said, that's for number 1. So I'm not going to give you the answer. I want you to solve it. Number 2, what was the acceleration for the ball during the first 4 seconds? So again, we're going to use our formula. A is equal to VF minus VI over T. And I'm going to help you a little bit here. So for only looking at the first 4 seconds, I'm actually going to draw my line here. That's where we're going to stop looking at it. So our final speed recorded at 4 seconds is 8 meters per second. So VF is going to be 8. Our initial speed, we look here, it is 0. And our time we're going to be looking at, it says only to 4 seconds. So I'm going to use this information and plug it into this formula to solve for acceleration. For number 3, it says during which periods did the ball travel at a constant speed? Remember, go back and look and see what does a constant speed look like. I'm not going to say. I want you to tell me what seconds did the ball travel at a constant speed. Number 4, during which period did the ball experience a negative acceleration? Remember, negative acceleration, your initial velocity is greater than your final velocity. So you tell me when. And then number 5, what can you infer about the shape of this hill and explain your answer? What can you tell me about what was this ball doing? All right, good luck. Thank you for watching the video. Answer the questions and then send me your answers from the handout. Thanks, guys, for watching.